This section will provide an explanation of the least squares criterion. For our criterion of best fitting line, we use the least squares criterion, which states that the line we fit to the data point must be such that the sum of the squares of the vertical distances from the points to the line be made as small as possible. So again, that definition for least squares criterion is the sum of the squares of the vertical distances from the data points x, y to the line is made as small as possible. The least squares criterion is shown below, where D represents the difference between the y coordinate of the data point and the corresponding y coordinate on the line. Thus, if the data point lies above the line, D, or the difference, is positive, but if the data point is below the line, D, or the difference, is negative. As a result, the sum of the D values can be small even if the points are widely spread on the scatter diagram. However, the squares D squared, or D times D, cannot be negative. By minimizing the sum of the squares, we are in effect not allowing positive and negative D values to cancel out one another in the sum. It is in this way that we can meet the least squares criterion of minimizing the sum of the squares of the vertical distances between the points and the line over all points in the scatter diagram. We use the notation y hat equals a plus bx for the least squares line. A little algebra tells us that b is the slope and a is the intercept of the line. Note that this is conceptually similar to what we have learned in college algebra for the equation of the line, y equals mx plus b, where m is the slope and b is the y-intercept. Our procedure is listed here as follows. The requirements are to obtain a random sample of n data pairs where x is the explanatory variable and y is the response variable. The first step is, using the data pairs, compute the sum of x, sum of y, sum of x squared, sum of y squared, and sum of xy, then compute the sample means, x bar and y bar. Step 2, given that n is the sample size and all the values that have been computed, you are ready to compute the slope b and y-intercept a using the computational formulas shown here. Be careful. The notation sum of x squared means first square x and then calculate the sum, whereas sum of x within parentheses squared means first sum the x values and then square the result. The equation of the least squares line computed from your sample data is y hat equals a plus bx. Note that for inferences in section 11.4, the data pair should have a bivariate normal variation. That is, for a fixed value of x, the y value should have a normal distribution, or at least a mound-shaped and symmetrical distribution, and vice versa for a fixed y value. Chapter 7 discusses normal distribution.